So it is finally time for us to see our robots in action. And for you to understand the videos I'm going to show you, you have to watch the previous videos and especially the last video before this one so that you understand why the robot behaves the way it is according to the code that we wrote. Okay, so I'm going to first demo when I want the robot to move backwards. And like I explained, this is all dependent on the reward function that we defined. Okay, so you can see that the robot is standing still. It is not because the algorithm is not working. It is standing still because the robot needs time to learn. So as it is there, the interpretation you have is that it is mainly taking the do nothing action because that is what it thinks is the best action. Probably it has taken it over and over because this is stochastic. There's some random number generation in there. But then over time, the robot will learn to optimize for the action that you want it to take based on how we have defined the reward function. So what it means is that the reward function has been designed such that when the robot takes a step forward, it will be penalized. And if it stands still, it will be penalized and it will get a positive reward when it begins to move backwards. So yes, this is taking some time, but as the light is blinking, the code is actually running on the robot and it is learning from the environment. It is still doing trials and errors. It is standing still, and now you see that it has taken a step backwards. And what happens is it stood still, got punished for so long, and then it took a step backward. It realized that it got a positive reward. So you can see that now it is taking more of the action that we want it to take, which is moving away from the obstacle. So the obstacle is this brick, wood, or something that I have placed here. And it's important that you make your obstacle something that is not transparent. Otherwise, the infrared light will not bounce back and it's going to go through it. So your algorithm will seem like it is not working. So as you can see, the robot is continuously moving back and back and back. And all this is because of how the reward function has been designed to punish it for taking a step forward and to punish it for doing nothing or standing still. So I'm going to the next demo, which is getting the robot to move forward. And so I started there, and once again, it's going to take some time for it to learn. So in a live environment, the useful thing for you to do is to save what the robot has learned. And in this particular instance, what you have to do is to save your rewards list, the action count list, and then the action values list. Once you save this, the robot will always start from the most recent knowledge that it learned from the environment. So as you saw, it took a step forward and then now it is standing. It has taken a step backwards, it took two steps backward, and now it has realized that those backward steps or the standstill steps are not the most optimal thing for it to do. So you can see that it has to move closer and closer and closer and closer. And because this is not an obstacle avoidance robot, it will move all the way into the obstacle. And it is still stochastic, so it has the ability to move backwards or even stand still, even though it has found the optimal action. Don't forget that in Epsilon Greedy, you actually allow the robot some time to explore. So this is the MAB action making the robot move forward. And the last thing is we want the robot to stand still. So what you have to do is you need to make sure that in your reward function, you penalize it for moving forward, you penalize it for moving backwards, and you give it a positive reward for standing still. So it is standing still not because it has learned to stand still. It is still in the process of learning. And because it is once again stochastic, you will see that it will take some steps forward or some steps backwards. If it could even take 4 5 steps forward, 4 5 steps backwards. It could take longer time because this is stochastic. But the most important thing here is that eventually your robot will find out the most optimal. So it took 2 steps backwards, 2 steps forward, and now it is standing still. And I ran this for over 2 hours when I built it first, and I could count the number of times it took a step forward or backwards, and it was less than 6 within those 2 hours. So what happened was it started off randomly, it learned the best action, and once it realized that the best action was for it to stand still, it stood there for the entire 2 hours without moving an inch. So this, ladies and gentlemen, is a very simple algorithm the multi-armed bandit algorithm. It is very useful not only in robotics, you can apply it to gambling, you can apply it to online trading, you can apply it to advertisement placement, you can also apply it to A-B testing. And in any scenario where your task is to optimize actions or take optimal actions under uncertainties. So that is it. Thank you very much for staying with me throughout. If you haven't subscribed to the channel, please do so, and so you can get notified once I publish new videos. Thank you, and see you in the next series.